Section 3: Thunderstorms and Flash Floods. Digging deeper. Development of a thunderstorm. Thunderstorms can be caused by air rising along either cold fronts or warm fronts. The most intense thunderstorms are usually connected with cold fronts. The advancing cold air forces the warm air to rise along or ahead of the cold front. There are two factors that determine if a thunderstorm will develop. One is the temperature difference between the masses. The greater the temperature difference, the greater the chances that a thunderstorm will develop. Also, the more rapidly the cold air mass wedges under the warm air mass, the greater the chance that a thunderstorm will form. Thunderstorms can also be caused locally by convection with a warm and humid air mass. A thunderstorm is a relatively small, short-lived weather system. A typical thunderstorm is so small that it may affect only one section of a city. Most complete their life cycle in less than an hour. The three stages in the life cycle of a thunderstorm are called cumulus, mature, and dissipating. Severe weather is most likely to occur during the mature stage. The initial stage of thunderstorm formation is the cumulus stage. During this stage, cumulus clouds build upward and laterally. Growing cumulus clouds have flat bases and towering tops. They resemble cauliflower as seen in Figure 1. Cumulus clouds develop where air ascends as an updraft. As the air reaches higher levels in the atmosphere, it expands. This is because the pressure is lower at higher levels. The air cools as it expands because some of the thermal energy of the air is used up in the expansion. The cooling of the air causes some of the water vapor in the air to condense. This produces clouds. No precipitation occurs during the cumulus stage of thunderstorm development. Most cumulus clouds do not develop into thunderstorms, but all thunderstorms begin with cumulus clouds. The interactions between the warm air rising and its cooler surroundings during the cumulus stage generates a positive feedback loop. Water vapor in the air condenses and forms droplets. It also releases thermal energy into the cloud, warming the air. This, in turn, causes the air to rise more rapidly and higher in the atmosphere. There, more expansion, cooling, and condensation occur. As a result, thermal energy is released into the cloud. The air continues to be warmed. This process continues upward. A towering cumulus cloud is formed. Where did the energy released by condensation come from? The answer lies within the process of evaporation. During evaporation, liquid water is vaporized. It becomes a gas in the atmosphere. During this change in state, water molecules absorb thermal energy from their surroundings. In contrast, during condensation, water molecules change from a gas to a liquid. The stored energy is released back into the atmosphere. A thunderstorm that produces severe weather requires a very strong updraft. Updrafts can rise at 5 to 10 meters per second and can exceed 30 meters per second for large storms. This builds the developing thunderstorm cloud to great altitudes. Thunderstorm clouds are called cumulonimbus clouds. Most of the time, convection alone is not strong enough to build a cumulus cloud into a cumulonimbus cloud. Nimbus means rain. In order for this to happen, the updraft must be strengthened in some other way. Frontal wedging, orographic uplifting, or converging surface winds can strengthen an updraft. They cause cumulus clouds to build vertically into thunderstorm clouds. If an updraft is strong and persistent, the cumulus cloud becomes taller and taller. Eventually, it produces rain, hail, or even snow. Once precipitation begins, the thunderstorm has entered its mature stage. Falling raindrops or hailstones drag the surrounding air downward. This forms a downdraft alongside the updraft. During the mature stage, precipitation is heaviest, lightning is most frequent, and hail and even tornadoes may develop. As a rule, the higher a thunderstorm builds into the atmosphere, the more likely it is to produce severe weather. Precipitation and the downdraft eventually spread throughout the thunderstorm. At this point, the system enters its dissipating stage. Precipitation tapers off and ends. Clouds disperse. The chances for severe weather decrease greatly. Thunderstorms and flash floods. Thunderstorms can produce torrential rains. Usually, the rain does not last very long and does not cause serious problems. Sometimes, heavy rains can last for hours. This can lead to flash flooding. A flash flood is a sudden rise in the water level of a stream, river, or human-made drainage channel in response to extremely heavy rains. Flash floods can also occur when a brief but heavy rain falls over the entire area of a very small watershed. In some places, water might overflow stream banks and collect in low-lying areas. The life cycle of a thunderstorm cell is typically less than an hour. How could torrential thunderstorm rains last for many hours? Flooding usually results from more than one thunderstorm cell. Flooding thunderstorms are most likely in mountainous terrain. Here, a persistent flow of humid air up a mountain slope can cause thunderstorm cells to develop and redevelop over and over. Outside of the mountains, another possible cause of flooding rains is a succession or train of slow-moving thunderstorm cells. These are the cells that mature over essentially the same area. Thunderstorms also move slowly when the steering winds in the middle and upper part of the troposphere are relatively weak. The dotted line you drew on your map outlined the boundaries of the area where water from raindrops would drain downhill into the Sauk River. A drainage basin is the geographic area from which all the rain that falls eventually flows to the same final destination. A drainage basin is also called a watershed. Heavy rain falling on the upstream part of a drainage basin might cause flooding downstream. The flooding can occur in areas that received no rain. In other words, just because it is not raining where you are does not necessarily mean there is no flood danger. Flash floods may be more likely in an urban area than in the surrounding countryside. The reason for this is that the rain in the country can seep into the soil. In the city, rain cannot seep into asphalt or concrete parking lots, roads, and driveways. Water also cannot penetrate frozen soil. Instead, the water runs off these surfaces into nearby streams or other drainage ways. Storm sewers also channel water from roads into streams. Streams receiving so much water at one time can overflow their banks quickly. Also, storm sewers sometimes clog or cannot handle excessive volumes of water. The water backs up into the streets. The flash flood hazard is serious in mountainous terrain. In these areas, river valleys are narrow and deep. There are no broad areas next to the stream channel where the water can spread out. Therefore, stream levels can rise very quickly. If the river valley also contains roads, campgrounds, or houses, a flood can be very destructive. When a river overflows its banks in a non-mountainous area, Excess water spreads over a broad, flat area adjacent to the river, known as a floodplain. Floodwaters are usually shallow. In mountain valleys where floodplains are also very narrow or non-existent, floodwaters are much deeper. Also, in non-mountainous areas, roads and buildings usually are not located as close to the river as they might be in the mountains. Safety tips for floods. Flash floods can strike at any time and any place with little or no warning. In mountainous or flat terrain, distant rain may be channeled into gullies and ravines, turning a quiet streamside campsite into a rampaging torrent in minutes. City streets can become rivers in seconds. Observe these flash flood safety rules. They could save your life. Keep alert for signs of heavy rain, both where you are and upstream. Watch for rising water levels. Know where high ground is and get there quickly if you see or hear rapidly rising water. Do not pitch your tent in a dry stream bed. Be especially cautious at night. The danger is harder to recognize then. Do not attempt to cross flowing water that may be more than knee deep. If you have doubts, do not cross. Do not try to drive through flooded areas. If your vehicle stalls, abandon it and seek higher ground immediately. During threatening weather, listen to commercial radio, television, or NOAA weather radio for weather watch and warning bulletins. Lightning and thunder. All thunderstorms, no matter how weak, produce lightning. Lightning is a powerful electrical discharge. You probably have experienced an electrical discharge. If you walk across a carpet in a dry room and touch a metal doorknob, you may get a shock. If the room is dark, you may even be able to see the spark. The tips of your fingers develop an electrical charge that is opposite that of the knob. The electrical discharge is a flow of electrons to the positively charged surface. Electrons are negatively charged subatomic particles. An electrical discharge reestablishes electrical equilibrium between two objects. That is, it evens out the difference in an electric charge. Lightning is also an electrical discharge. However, it operates on a much larger scale. It involves a much greater difference in electric charge than a common spark. As a cumulonimbus cloud forms, its upper regions develop a positive charge. A much smaller region near the cloud base also develops a positive charge. In between, a pancake-shaped zone of negative charge forms. Scientists do not know exactly why this happens. It is difficult and dangerous to study a thunderstorm directly. However, they think that water droplets and ice crystals within the cloud develop different charges. Updrafts and downdrafts deliver charged particles to different parts of the cloud. During this charge separation, the cumulonimbus cloud induces a positive electrical charge on the ground directly under the cloud. Normally, Earth's surface carries a negative electrical charge. Air is an excellent electrical insulator. As a result, as a cumulonimbus cloud forms and charges separate, a great potential soon develops for an electrical discharge. When a thunderstorm cell enters its mature stage, the electrical resistance of air breaks down. Lightning discharges. This evens out the electrical charges. Lightning forges a path between the cloud and the ground or between two clouds. Less often, it forges a path between two different parts of the same cloud. Of all the lightning flashes that you see when a thunderstorm is in progress, only about 20% strike the Earth's surface. A lightning bolt and the thunder it produces happen at the same time. Recall that nothing travels as fast as light in a vacuum. It travels about 1,000,000 times faster than sound. As a result, you see the lightning almost instantaneously. You hear the thunder later. Sound travels about 330 meters per second. So in 5 seconds, the sound of thunder travels about 1,650 meters, or almost 1 mile. Therefore, every 5 seconds between a flash of lightning and the sound of the thunder it creates equates to about 1 mile from the location of the lightning bolt. Lightning has caused the greatest number of deaths due to severe weather. There has been a lightning detection network that covers most of the continental United States since 1989. During that time, an average of 20 million cloud-to-cloud ground flashes has been detected every year. You see the electrical discharge of lightning before you hear the clap of thunder because light travels faster than sound. Lightning heats the air around it to very high temperatures, about 20,000 to 30,000 degrees Celsius. The quick rise in air temperature comes along with a huge rise in air pressure. This rise causes a shock wave. The shock wave then moves outward to make a sound wave that you hear as thunder. Sound waves are formed all along the path of lightning. The first thunder you hear is from the part of the lightning bolt that is closest to you, where it strikes the ground. Other sounds of thunder reach you from parts of the lightning bolt that are farther away from your ears and higher in the sky. This explains why thunder keeps rumbling after a lightning flash. Thunderstorm cells more than about 20 kilometers away are too far for you to hear their thunder. The lightning you see from around these storms is called heat lightning. Lightning safety tips. Lightning is the most frequent during the mature stage of a thunderstorm's life cycle. However, lightning can strike the ground many kilometers beyond the parent thunderstorm. That means that lightning can strike areas where rain is not yet falling or has stopped falling. In other words, lightning is a hazard before, during, and after a thunderstorm hits a particular area. Lightning is most dangerous when it strikes something that readily conducts electricity. For this reason, during a thunderstorm, it is wise to avoid metallic objects such as lawnmowers, wire fences, and telephones. Contrary to popular belief, an automobile's tires provide occupants with little or no protection from lightning. Lightning that strikes a motor vehicle flows through the steel frame to the tires and then to the ground. Without direct contact with the metal frame, passengers usually escape injury. Lightning also tends to follow the shortest path between the cloud and the ground. Therefore, when thunderstorms are threatening, stay away from high places. Places such as hilltops or tall objects such as isolated trees might attract lightning. If you are with someone who has been struck by lightning, it is important for you to know that the person does not carry an electrical charge. It is safe to touch the person and provide first aid after the lightning strike.